I'll start recording here on this computer, and I'm going to go ahead and share my screen. Okay, so generics. Okay, so what is a generic? And let's go ahead and just stop sharing for a second. So, yep. All right. Sorry, I just wanted to make sure I didn't have the answers for the, or at least too much of the answer written down. So, since I'm just reusing a file from summer 1. All right, so here we go. We've got ourselves our file, and I'll be going over this in the various parts of this, but I've imported array list and list. Now, again, what is a list? A list is pretty much our first data structure. It is exactly how you'd expect it to a list to work, right? We work with lists all the time: to-do lists, shopping lists, a list of tasks. The important thing about lists is that everything has kind of a slot that it fits in. So there's so you can definitely refer to the first item in the list, or 0th, I guess, for computer scientists, and the last item in the list, or maybe the 5th item in the list, right? Things in a list have an order, whether or not we use that order for any significant reason, right? In a shopping list, it doesn't really matter where the thing is in the list, but there's still definitely like the top of the list and the bottom of the list. So now when we create a list like this, we can say list, we can say, well, let me go ahead and do this. Array list is equal to new array list, and you see that we're already getting some warnings saying raw use of parameterized class array list, which sounds like a whole lot of gibberish, which it is. I admit it's kind of ridiculously gibberish. So but I just want to say this is all you have to do to make a new array list, which is much easier than making an array, in my opinion, because I always forget how you make an array, right? An array, you make it. Oh, right. I have to put the bracket things to make an array, and then I have to say new, and then I never use a constructor. I always use how big of an array I want, which I always have to kind of look up. Yes, this is in Java. Okay, so here's the thing about these. Now here's the thing to note. I've started out by writing list, and this is because, again, with objects, that we have that objects can have an is-a relationship, right? An array list is a list. If we go into the source code of array list, which is pretty cool that you can do that, right? We see that a array list extends abstract list, and abstract list extends abstract collection and implements list, meaning that it is. So what does it mean to implement something? Well, a list is what we call an interface. Okay, and what the heck is an interface? An interface is basically saying, hey, to be considered a list. So we have this interface list, which simply says, if you want to be considered a list, you got to fill out all these methods, all these empty methods. They got to be filled out if you want to be considered a list. So an abstract list fills out some of those methods. It's what we call an abstract class, which don't really have to panic about, because you're going to see it here and we're never going to use it. It's kind of the halfway point between an interface and an implemented class, or sorry, a fully written class, which is to say that basically that some of the methods are written and some are not. Like this guy is abstract, meaning that he's not filled out. And so if you implement it, so if you extend an abstract list, you got to do that. You extend a class that's fully or partially written, but you can implement as many classes as you want. It's a weird way to do it, but the point being is that what is the important thing to take away from this? An array list is a list. Okay, so as a result, we can write list is equal to a new array list. So we can store any kind of thing that is a list in this variable, be it an array list, or as we'll see later, a linked list. All right. So now the cool thing is that we can, by default, because we don't know what gets stored in an array list, we can just kind of add anything. See, it says add object. Object is anything, right? So I can add 1, and that's cool. Even though it said an object, by the way, notice I added a notice that I added a integer here, and that's a primitive, right? Okay, that's interesting, right? This is a primitive. Primitives aren't objects, right? Well, that gets into another thing that's important to understand when we get into generics. And also notice our crazy amounts of warning that we're generating on every single line we're using the list, because that's just Java telling us we aren't using it correctly. And you haven't been, you don't use it this way since Java 5. Okay. So anyway, how are we adding a primitive to something that accepts an object? And the answer is that Java has this really useful automatic feature called auto boxing, which is that we have these classes called. So here I have integer x is equal to 5. So here what I've got is a I've got an int, and I can store it inside of integer x. And what that does is that it automatically converts our ints to integers. Okay.
I think I remember something like this. So basically, like if it's a cap, like the way I remember was, if it wasn't capital, like I, that was like the object version of the integer.
That's completely correct. That is completely correct. Basically, and that's also because that every kind of class in Java has a every kind of class that we write in Java, it starts the practice is that we write our classes to be capitalized. So right, so here we have integer x is equal to 5, and it's just an object that basically it's a wrapper class, is what the proper term is. It wraps around a primitive, and it's just like how we can write string s is equal to apple, assuming it can spell apple. Apparently it's very hard to spell that word, and we don't have to, and even though string is an object, we don't have to write new string, right? I don't have to do that. So and Java will automatically convert any kind of object to its wrapper class as needed. Also, if you need to convert from one to the other, perfectly fine. What you can't do, by the way, is that, say here I've got a double D. So here's the only thing you can't do with wrapper classes. I've got double D is equal to 5. That doesn't work. You can't convert from a primitive to a different type of to a different wrapper class. That doesn't work. You have to have a double. So anyway, you're rarely going to use these classes as is. Most of the time, Java just turns it into these wrapper classes so you can use them automatically. So here I can do list.add, list1, list2, list.add 3. So let's say I've got a list of numbers. This list is made up of numbers, and I want to add them all up, right? So let me write a for loop. For I, boom. Okay, so for int I is equal to 0, I is less than. Again, this is one of the most annoying features about Java, in my opinion, and I don't have a lot to complain about Java, to be honest. I really. Every language has its own quirks, but this is the one thing that I find annoying, which is that if I want to get how big a list is, it's list.size with parentheses. If I want to get how big a string is, it's strings are dot length with parentheses, arrays are dot length without parentheses, and everything else is dot size with parentheses, which is annoying. It's like one of those things that's designed to be a test question to deliberately dock students points for reading for reading quickly during an exam. It's just, whereas in Python, you just ask, oh, how big do I want something? I'm going to use the length function and just I toss in the thing I want to know how big it is into the length function, and the length function tells me. But regardless, that's how it's just one of those quirks, and I understand why after working with Java for so long. But all right, so list.size. Right now, rather than doing a subscript notation like this, we can't really use subscript notation on something that's not an array. To get a value out, we use .getI. So here, what I'm going to do is, if I want to sum all these things up, int sum is equal to 0, right? If I want to sum all these things up, I'll just simply say list.getI is equal to, and I'm going to say sum plus equals list.get I, and I get an error here. And why? Well, it's saying that, well, let me go ahead and rewrite this, right? Sum is equal to sum plus list.getI. That's what the plus equal was, right? So here it's saying that you cannot, and I get the same error, you cannot add, you cannot apply the plus function to on a int to an object. Now, what's the issue? Well, it's a list of objects. We don't know what's in it. It's objects, right? There's nothing with that. There was nothing stopping me from doing this. List.add hello into this list, right? It's a list of objects. I can do anything I want. So if I want to add things together using a list, even though I know the only thing in here is are ints, is that I have to cast. I have to cast this and tell Java, don't worry about it. I know it's in here. It's an int or an integer. I said, I know you say it's an, I know I'm saying it's an object. I know that that you think it's an object, but in reality, it's an integer, and I'm a programmer, and I know more than you. I know better than you, Mr. Computer, sir. Okay, so let's go ahead and run this. And we see we get the answer 6. However, if I decide to, if I'm careless with my list, which is really possible when you don't have any type safety features added, like this, and we go ahead and add hello back in, what's going to happen? I run this and I try to convert a string into an integer, and I get an exception saying we cannot cast these. So one of the big kind of things we can do here. So one of the big safety features we can do here is generics. It kind of avoids both these issues of having to cast as well as preventing things. If I want a list of just integers, I can specify that this is just a list of integers. And we kind of saw, and we saw that we can do this with this notation over here, the E. And this says basic, and notice over here that we let's see where it is. Yep, T2 array. We'll see, like with the add method over here, E, that we see this E over here and this mysterious E. And what basically this is a generic. And a generic says is that when you create the class, when you create an array list, you can specify what the heck you want E to be. So you can specify if you'd like all the E's in this code to be replaced by a different class type, which I do. A list of integers. So the way you read this is with the of word, right? List of integers is a new array list made of integers. And notice that that it's faded out. This is, we can just simply erase that and use something called diamond notation just to speed it up. It's called diamond notation because when you put the lesser than sign and the greater than sign, it looks like a diamond, right? So what we've got here is a list of integers is equal to a new array list. And now notice the warnings are gone. We can add numbers to this. And if I do list.add, notice that this add method, it no longer accepts an object. It accepts an integer. If I were to change it to a string, now we see that the add method has been replaced by a string, but furthermore, notice right over here, we get an error saying that it's a list of strings. The only thing it's going to accept are strings. Make sense? So it's going to error. So it creates errors to prevent you from adding a type that you can't use. Now I can add in 4 and I don't need this casting anymore. I can just write sum is plus equal to that, and I can run it. Now, what's also cool is, let's see, we do have actually, it looks like a number of our students have actually, 1, 2, 3, 4, 5, 6, 7. Sorry, 6 people. So, okay. So what's also useful over here is that we can do this with functions as well. So over here, we have this function sum, which is pretty much what we wrote down here, but we've done it as a function. So over here, I'll just simply say sout sum of, and notice that this function says it takes a list, but specifically a list of integers, right? If I were to make a list of strings, let's call it words, is equal to new array list. Okay. And if I tried to pass in words, it's going to go, hold up. This is a list of strings. You gave me a list of strings. I want a list of integers. Okay, so list of integers. And now we can run it and it's gonna do what we did. Oh boy. Do exactly what it says on the tin. Now for your assignment. Now, mind you, we can do this when we know exactly what we want. For your assignment, though, we cover stuff that we don't necessarily know what the type is. So like our first thing for our assignment is our isUnique function. So what is unique? IsUnique basically is the first problem in our assignment for the array lists. And it says, basically it takes in a list, and it goes through and says, hey, are all the things in the list unique? Basically, are there any repeats of anything? Now, here's the thing. We want it to accept any type of object. We want any type of list. So in order to do that, what we do is we say we accept generic lists. So notice over here, it's a list of E's. What the heck is an E? Well, that's going to be determined when we call it. So this is pretty cool. List of words. So over here, I'm going to go ahead and add something to words. Words dot add. Hello. So we don't know what isUnique is going to do. So, or rather, what isUnique is going to use. So here, if I pass in list to isUnique, And how do you write a generic function? It's very simple. You just simply put this marker, this what we call the generic marker, between the static and the return type. And you only need to do this for static functions. And what this is saying is that basically anything is that we're saying that E is a generic type. If you see an E, it's going to be replaced by something depending on what the user passes in, what the programmer passes in. So one mistake I see from beginners is that if they're writing something like this public static list of integers, they'll put in, oh, this takes in integers. Integers the generic type, so I'm going to put an integer there. Notice the integer changed color, and then you get an error over here. And then it gets really weird. And what's going on here is that it thinks that integer is the generic type. It thinks integer essentially is E. It's thinking essentially integer is no longer a type, it's a variable. So integer is no longer a defined type. It is a type to be defined. That is the best way to think about that. Now, if we do public static E over here, we can use E's just like any other type. E item is list.getZero. And I do go into more detail on this in my videos. So here, what I'm doing is I'm going to get the item at index 0. And the idea here is we don't know what type E is going to be until I pass it in, until I pass in what the list is. So if I pass in a list of strings, all the E's are going to become strings. If I passed in a list of integer, all the E's are going to become integers. So here I'm running this function with a list of integers. And what we get here is that I printed out what this did. So we got the item at index 0, which doesn't really matter what it is. And I printed out what is its class type. Well, it's a list of integers, so it printed out integer. And item, instance of integer. That's a true or false statement. It's basically asking, is the item an integer? Why, yes, it is. Return true. So it passes back true to us. Is the item a string? Integers are not strings, so false. Now, if I pass in words, we should get string, false, and true, because now all the E's are going to be replaced by strings. So what's cool about this is that you can ensure that anything you're passing in, they're all going to be the same type, which is nice. Okay. So what about so there's other functions like this that we'll see. Like, for instance, we have is unique. That's going to take in. We don't know what type we're going to pass into is unique. So we write it with the generic type. But for problems like all multiples, which is the second problem, which says given a list of integers and a number X, give me a new list with all the numbers from the list that are divisible by X, which I have, again, more examples. But the point being is that we're dealing with lists of integers the entire time. I'm taking in a list of integers and I'm returning the list of integers. So using this generic marker over here that highlights everything green in my IDE, don't need to use that. I know what type I'm using, so I don't have to say we don't know what type I'm using. That's what this is for, when you don't know what kind of list or kind of generic you're going to be using. Here, we know what we're going to be using. It's integers. So we just write it public static. I'm returning a list of integers. So the person who's getting the return knows exactly what kind of list they're getting back. Similarly over here with is permutation, which is another one. This one has two lists, and this is where the generics really become useful. This ensures that list A and list B are exactly the same type. So it ensures that list A is going to be and list B are going to both be like list of strings, or they're both going to be list of integers. But what you're not going to get is one being a list of strings and one is being a list of integers. So that's very useful there. Okay. Any questions? Any clarifications?
I have a question. So essentially for homework, we're supposed to write a code that's going to return what the generic code is asking for.
I'm sorry, I couldn't quite make that out.
So for homework, essentially we're writing a code that's going to then be true for what the generic code is asking for. Like I see you already have methods and functions written, and we're just supposed to write a code that's gonna turn that true or false.
Right. Well, the is unique should work for anything, right? Same with the
Okay.
permutation. It should work for anything. The with your homework, and I detail this in the homework document. You want to make sure that it works with generics. In other words, the idea here is that your code should not produce any warnings. And if you don't use generics, you're going to get a ton of warnings because lists expect. So what happens if you don't use a generic? The reason you get warnings is because Java really was expecting that. And so the only thing it can do is lists of objects, which probably wasn't what you wanted, because if you want it to be useful, you have to start casting it. Anything else related to the second assignment or the first assignment or not, or whatever? All right, so I'm going to give you a couple minutes to get situated and get started on your work. I'll be right back. Okay. And again, if you weren't here, if you just feel the need to get up and walk around, or because, working for 4 hours straight, actually it's closer to 4.5 or 4 hours, 15 minutes. If you need to walk around or take a break, just let me know in chat, just saying that you're going AFK. That's all. You don't even need to tell me why. Just tell that way. If I call on you for any reason, right? That way I'm not like going, can they hear me? Is there a problem with their microphone? So, all right.